Hi everyone, I'm Dr. Ryan Sandell, and I'd like to welcome you to this 14th and final meeting of an Introduction to Phonology at the Ludwig-Maximilians-Universität München. In our final lecture, we're going to be discussing phenomena of tone and intonation. Just to review the things that are happening, that are going on in the last weeks of the course, I've asked you to read the chapters on these topics from Hayes and Tracy Allen Hall's book. And on this Wednesday, the 6th homework assignment will be made available, which should then be due the following week. Today, we're first going to discuss the different possible usages of pitch in phonology, that is, how pitch can play different roles in phonological systems. Then we'll briefly look at so-called tone languages and see so-called autosegmental representations for being able to describe the phonological processes involving tone. And finally, we'll take a brief look on the basis of our textbook at the intonational phonology of English. So, to begin, let's try to define exactly what pitch is, since pitch interfaces directly with tone and intonation. Fortunately for us, in contrast to other phenomena that we've talked about, and for instance, in contrast to stress, which we discussed last week, phonological pitch has a direct, measurable, and observable phonetic correlate. And this phonetic correlate is the so-called fundamental frequency of a speech sound, which corresponds to the rate at which vocal cords open and close. And this is concretely measurable in cycles per second, or hertz. So in technical acoustic terms, one talks about frequency measured in hertz. When we go to the level of phonology, then we come to talking about pitch. And when we use the term pitch, what we mean then is the perception of this fundamental frequency. So we have the acoustic object that exists in the world and which we can record and measure using a computer, which I'll show you in just a moment. But when we talk about things at more the psychological level, at the level of speech perception, then we use the term pitch. And today we'll be using the terms pitch and tone and intonation. Now, there exists a lot of software which can be used to easily visualize and measure fundamental frequency in the production of a sound. And I'll show you this briefly using the software Praat, which is probably the most common piece of software in use for doing kinds of phonetic analysis, formant analysis, and looking at spectrograms. So I have here a recording that I just made of myself. I'll play this for you. Here's an example of a pitch track made with Praat. Let's hear this once more so that you can. Here's an example of a pitch track made with Praat. Now, in order to see some of the acoustic properties of this sound, one can, after having read in the file, in order to do that, one simply, I actually recorded this sound here. So I had clicked on record stereo sound, and then you see this dialog box. And I recorded the sound to create the object here in Praat. And when you click on View and Edit, we can look at the sound. So I actually already had an editing window here, and we can see the spectrogram over here, or on the lower part. An example of a pitch track made with Praat. And I've just cut it a little bit, so we're only hearing part of that. I'm going to extend this so that we have the whole recording from beginning to end, more or less. And in order to add pitch information, intuitively, you might click here on Show Pitch. And when I click this, Praat nicely adds in some little blue lines, which will usually correspond to, in this recording, vowels or other heavily voiced parts, sonorants in the recording where pitch differences can be easily heard. And in fact, I've already altered this to a little bit so that, in fact, Praat by default shows a pitch range. We click here on not advanced pitch settings, but on pitch settings. By default, Praat shows a pitch range between 75 and 500 hertz, but as you can see, that sort of compresses the range here a little bit, and that's not so helpful for us to clearly see the differences in pitch. So I'm going to put the range here between 50 and 200 hertz, which is a bit better for being able to see differences in pitch being produced by a human voice. So let's listen to the recording once more now. Here's an example of a pitch track made with Praat. So you can see that for some reason it doesn't quite pick up. Here's an example of a pitch track made with Praat. So here's the last vowel at the very end, and we can see that the pitch here began at a rather higher range and then stayed in a somewhat lower range before rising a little bit at the very end. And sometimes you can get pitch effects due to other surrounding consonants a little bit as well. But the important thing for us is simply to see here that these blue lines, which Praat is able to draw in, show us differences in pitch height. And when we look at an example from a language with contrastive phonemic tone, we'll look at just such a drawing where we have the pitch tracks that show us differences in height of pitch. Quite naturally, here 200 hertz means a higher pitch, a higher frequency, and 50 hertz would be a lower pitch in perceptual terms. Now, let's talk about the classification of languages in terms of how they use pitch. So our textbook, Hayes 2009, proposes a division of languages into 3 types concerning their use of pitch. So Hayes here distinguishes between tone languages, that is, languages that have phonemic contrast in pitch as part of the phonological information in the lexical entries of morphemes. So say the word for frog might be marked for high pitch, whereas the word for goat might be marked for low pitch, and those pitches would be systematically contrasted on different morphemes. Then come so-called pitch accent languages, in which pitch supposedly plays a function similar to stress, and thereby contrastive pairs can be made based on the position of some pitch. In a lot of languages that are treated as having a pitch accent, that pitch would probably be a high tone. And finally, the third type consists of intonation languages, where pitch patterns, usually at the phrase level, seem to carry their own meaning, their own semantics, usually based on the information structure of the sentence. We'll talk about what that means a bit later on. And these intonation languages are usually languages that have word level stress. And for that reason, English will provide us a good example of an intonation language. However, it's worth noting here that one complication is that all 3 of these different types which Hayes proposes may or may not really have clear metrical stress in some sense. So stress in the sense in which languages like English or Russian or Italian seem to have stress. So for instance, Mandarin is a canonical tone language. The lexical entries of morphemes in Mandarin seem to carry information about tone, but it does also have stress with some effects on tone. Whereas it seems that Vietnamese, as far as I know, presents no clear evidence for stress phenomena, but also has contrastive tone. Then in the domain of pitch accent languages, there are languages like Seneca, an Iroquoian language spoken in the northeast of North America, which has pitch that is dependent upon metrical structure. So based on where prominence is determined to be, in the same way that a language might determine where the position of stress is, we can calculate the position of pitch in Seneca. Whereas Japanese pitch, as we'll see later on, seems to be largely independent of metrical structure. And there are also other languages like Lithuanian or Serbo-Croatian, which have contrastive pitch patterns, but which can only be realized on stressed syllables. And then finally, there are languages like English and Korean, which are both intonational languages, but it's clear that English has contrastive stress, where it seems that Korean does not. And in terms of this overall typology of tone languages versus pitch accent languages versus intonation languages, it's actually rather difficult to define clearly what pitch accent languages are, that is, what properties pitch accent languages have or do not have that distinguish them from languages with stress or tone languages. So for simplicity today, we're largely going to just look at languages that we would consider to be prototypical, relatively clear examples of tone languages, relatively clear examples of a pitch accent language, and clear examples of intonation languages. But throughout, you should keep in mind that there are further possible interactions between stress, lexical tone, and pitch, and the full range of typological possibilities, I think, has not even yet been fully described. And if you encounter grammars, a grammar of a language trying to talk about the tonal phenomena or pitch phenomena of a language, you should be quite careful and perhaps even skeptical in trying to evaluate exactly how that information is presented. Okay, so now that we've seen briefly how we can see pitch measured with help of a computer, and we've gone into this classification of the use of pitch in languages, we can pause before trying to describe in more detail exactly what tone, pitch, accent, and intonational languages concretely look like.